It's translated for you guys.
I would like to explain what this means and what it contains in simple words, without a lot of formula grammar. In order to understand this physically and the physiological background, we need to look at the interaction of the basic building blocks of organic life. The interaction of atoms, molecules, ions, and electrons. Their interplay determines the course of organic life, and thus the appearance, well-being, vitality, and fitness. As natural forces of self-preservation, these interactions practically take on the role of internal doctors. The adaptability of organic life to the constantly changing internal and external conditions is based on them. We do not know why this is so, but we have now learned how these processes work in principle. Here's an example. These are the fidgety molecules. They are very hard, but very mobile. The basic building block looks something like this. You could compare it to the solar system in space. The atoms are arranged in the middle, where the sun would be, and the electrons orbit around the outside. Practically like the planets around the sun. The whole thing is, of course, much larger to look at, but you have to imagine the large, empty space between all these particles. If we imagine that the atoms are as big as a soccer, then the electrons circle around them at the distance of a soccer pitch, a huge dimension full of emptiness. And yet, we can bang our heads on some door, and then realize how hard such a molecule is. In order to initiate a change, an interaction with the molecules, a supply of energy is required that changes the electron paths and brings them to a new energy level. And this energy is called activation energy. It's a bit like when you want to ride a sledge. You first have to get the sledge up the hill. That is the activation energy. Once you are at the top, it falls down on its own. The speed and duration only depend on the steepness of the hill and the height of the hill. So it's also comparable to a car stuck in the mud. You have to have the right momentum to push it out of the mud. And these activation energies are basically electromagnets. They are transmitted in the form of wave packets, also known as photons, and can initiate different cascades of physical and physiological processes. So these are the wave packets that arrive here. Each time a wave packet arrives, an electron moves to a higher level, indicated by the size of the circle. And vision shows that this energy supply can also be generated externally by electromagnetic fields. As we can see, a small photon enters our eye, and this photon activates the photoreceptors, and a cascade of physiological processes then leads to the visual process. Each molecule has a different activation energy. So one is large, one is small. You can see this in the picture below. Some molecules, such as enzymes or proteins, have several activation energies. It is important to note again here, these molecules are not rigid, but extremely mobile. But as I said, very, very hard. And this hardness depends on the electromagnetic force that keeps them in their orbits. So if we now look at a human being, the flashing dots practically symbolize the interactions. However, it can happen that internal or external influences, poor nutrition or other influences, can lead to disturbances, shown here in red in the body. And in order to resolve these, a supply of energy is required. And this ensures that these reactions remain capable of reacting, that these interactions start. In principle, the most important thing we can achieve is prevention. The Centronix KLOUD, the electromagnetic field system, is aimed precisely at the broadest possible activation of the molecular building blocks underlying self-preservation. Please note, the Centronix KLOUD is a wellness product. However, it is the equivalent to a medical device in terms of technology and function. The difference lies purely in regulatory tasks. If we now want to generate a pulse like this, we can do so by applying a voltage to a coil at the two poles, plus and minus shown at the top right, which changes over time as shown by the flashing green symbol. And according to this voltage curve, a magnetic field is created by the current flow in the coil and then generates a pulse. And this pulse can occur around 100 or 200 times per second. But it is not the frequency of the pulse that is decisive. That is an important part. What matters is the shape of the pulse, and it is therefore unsuitable or impossible to describe a pulse using frequencies. This requires completely different forms of description that can be defined mathematically. The next example shows this. Pulsating electromagnetic fields cannot be described in general terms by frequencies, as is often and incorrectly done, but by the bandwidth of their spectra. And these are made up, for example, of individual sine and cosine curves, as the next example shows. And the whole thing is then called Fourier analysis. Let's assume that the red curve on the left is the outgoing signal. And this can be simulated by the other curves to the right, pure sinusoidal curves with different amplitude and frequency, in this case 3. If you now look at the sum from the far right, simply add the individual pulse sizes of the amplitude. The result is exactly the red curve. And this system is called a spectrum. And if we now compare the latter curve, which we saw in the green image above, we can see that a very large number of different wave packets are required to simulate this curve. And that characterizes this formal signal, practically the bandwidth. And if we go into detail and want to represent this green left-standing formal impulse, then there are so many dashes that it is best represented by a surface. And the wider the area, the more spectral components this impulse contains. And the more spectral components this pulse contains, the more molecular activations of different types can be triggered. Let's take a look at an example. Earlier, on the left of the picture, the first signals can be seen. The first known pulse shapes were sawtooth, rectangular, or sinusoidal. There simply wasn't much else. And so if we look at the bandwidth now, the spectral width, green at the bottom left, it's relatively narrow. Then comes a square wave signal, which is a bit wider. Then comes the blue signal, which is the Beamer signal, which I invented in 1998. This is already relatively wide, and is also used very widely around the world, and is still in use. And another signal that we have just seen, this orange signal, shown again at the top right, shows a very, very broad spectrum. Practically broader than anything we've seen before. But what is so special about the cloud? It is the superposition, namely the superimposition of time-varying stimulation signals. This is absolutely new, and is also patented. The example summarizes what this means. If we look at the images on the left, we see relatively few activation points that are triggered by sawtooth, rectangular, or sinusoidal signals. The signal next to it, patented in 1998, the patent has since expired, generates considerably more activations and apparently also shows better effects. But what we want is the broadest possible activation, as much activation of different molecules as possible. And this has now become possible by superimposing these impulses on themselves or on slightly changing forms of stimulation. So the aim was to achieve even more activations, as shown here in the flashing image above, by superimposing. Here, two signals are superimposed and, depending on the form of the superimposition and the speed of the superimposition, a new signal is produced that is much broader in spectral terms. This is shown in the next image. So we have two signals here. In the top two lines, these are two signals that are slightly stretched compared to the previous one, and each signal is slightly different from the other and also changes constantly over time. The third line shows the sum, the addition of these two signals. And it is important to note that the pulses that are not so clearly visible here are simply shown in graphical form. If we now let it run, simply let a signal start. Then you can even hear it. You have now seen that the signals are constantly changing. There was also a slight rhythm, and you can see that the spectrum was constantly changing. This is now even clearer in this picture. Again, we have the two signals above, the red one, the one signal that is constantly changing over time. Important, constantly changing over time in terms of amplitude and timing. The lower signal as above, but also constantly changed compared to the first. And if we now start the pulse curve, we can see the result of the spectral composition in the lower graph. And what I want to say in advance is that you can clearly see that this spectrum is constantly increasing and broadening. Let's take a look at that. I'll stop now and then we'll see, practically we could see that within the 3 minutes or the 15 minutes of the treatment form. The spectrum is constantly broadening up to a range that the individual components go up to 22,000 pulses per second in terms of the transmittable amplitudes and frequencies. This means a very, very large number and accordingly, a large number of possible activations. What you may also have heard is that a rhythm has formed here. I would now like to demonstrate this to you using this example, because depending on the type of superimposition, different signal forms can be generated, such as here, for example. You have now heard, or thought you heard, the Radetzky March. But it is not. We have simply changed the rhythm of the amplitudes in the rhythm of the Radetzky March. And what sounds like the Radetzky March isn't really, it's simply an impulse gauge. But what we are now summarizing for the first time is that a very broad band spectrum can be represented by the appropriate superimposition. So this is the flashing arrow that overstretches everything that has gone before. And the slight shielding at the top is only intended to indicate that there is no sharp boundary in terms of amplitudes. Because, as we have just seen, the spectral composition is constantly changing over the course of time. What is important, however, is that this spectrum far exceeds all previous spectra, and therefore also makes a larger number of activations likely. And this is shown in the next image. Here we have all the different forms of stimulation again, and the width of the activated molecules is also shown depending on the width of the form of stimulation. So this is the absolutely new status as of 2021. We have just seen that a rhythm is possible here. And the superposition also makes it possible to initiate molecular activations via the synchronization of higher body functions in the form of functional cascades. For example, the regulation of biorhythms. Here, for example, the heart and respiratory rate, the number of steps when running, the activation and formation of proteins, and thus also cell division and cell renewal and many other rhythms. For example, menstrual cycles, etc. In other words, long-term activation principles. Various programs have been developed according to these possibilities, which we have simply designated here as P1 to P5, and given different names, but which should not necessarily have the same effect for everyone. This is a matter of experience that has been presented here, but in principle, it is probably feasible. One of the gentlemen from Centronix will provide detailed information on this later. What is important, however, is that the effect of electromagnetic irradiation continues even after stimulation. In other words, it does not end with the stimulation. It is comparable to throwing a stone into the water. The waves spread out after the stone has perhaps already hit the bottom. Or if you have a row of dominoes, The first tile may fall over and then take a whole row of other tiles with it. This is a cascade. Or, as the last picture shows, a tiny, very small push can trigger a huge chain or activation. We have now had to prove the whole thing, and we have demonstrated a physical effect using the example of a kind of wound healing, a symbolized wound healing. A purely physical, not a real healing process. To do this, we place two Petri dishes in a situation in which one is treated by a magnetic field from the cloud and the other is not. And these are real cells, truly biological cells. And then you can see this summarized here in the time-lapse recording. You can see that the separated cell layers grow towards each other, corresponding to wound healing. And the electromagnetic field-treated Petri dishes show a higher speed. In other words, we have proven that this is a genuine physical effect. There are thousands of studies. The problem is that these studies are mostly geared towards a specific goal. For example, wound healing or bone fracture healing or other issues, sleep disorders, and so on. But all these studies have the disadvantage that they always focus on a limited number of patients. In other words, all patients should be at least the same age, have the same diet and the same medication. But this is normally never the case. That's why I say that individual self-experience is crucial. In other words, use on a trial basis. And I would like to make this recommendation to everyone. If you are unsure, you should borrow the cloud. Now, there are still many manuals. These manuals often ignore the fact that these electromagnetic fields should not simply be used as fields across the board, but that it depends on the form of stimulation and the pulse repetition rate. This is often not done. Everything is simply lumped together. So that is not allowed. And it is also sad that more and more activities are emerging that deal with the pseudoscience of such magnetic field effects. I would therefore suggest that you always adhere to the guidelines in the Centronix manual. This is important and crucial. And now I hope you have understood what I wanted to tell you.
Okay.
Thank you for your attention and my suggestion. Use the cloud regularly and enjoy life.
Hold on, guys.
Thank you very much. Thank you.